In our previous video, we took a look at the crustal abundance of the three major elements, which were oxygen, silicon, and aluminum, and we said that those three elements are going to collectively make up the majority of the structure of our clay minerals. In this video, we're actually going to start to look at those various structures. I know for some of you that chemistry is not your favorite subject. I understand that. I encourage you to sort of bear with me through this discussion. There's some important attributes that I want you to understand. By no means do you have to be proficient in the chemistry. The one thing I would encourage all of you to do is out on D2L there are some handouts. And those handouts you can print, and they contain pictures of these structures that you're going to look at. So rather than trying to draw these in your notes, you can actually print these out. What we're going to be talking about is two basic building blocks that make up our clay minerals. We're going to talk about a building block that contains silicon and oxygen, and a building block that contains oxygen and aluminum. Why those elements? Because they're the most abundant elements. Our first building block is going to be called the tetrahedral sheet. The tetrahedral sheet comes from the bonding of silicon and oxygen together. And if we take a look at the basic unit, one silicon atom will bond with 4 oxygen atoms. Silicon has a +4 charge, oxygen has a -2 charge for each atom. We have 4 total oxygen atoms, so overall on that single structural unit we have an overall net negative charge. So we aren't able to satisfy all of those negative charges of the oxygen. Okay, the reason this structure forms this way is just nature. Silicon wants to be in a tetrahedral, a 4-sided arrangement with silicon. Each one of these silicon-oxygen tetrahedron can bond to itself. So in the bottom diagram you can see this one oxygen atom that's being shared. What can happen is you can have tetrahedron after tetrahedron after tetrahedron over and over and over, and it's in that process that you start to make a whole sheet of silicon-oxygen tetrahedron. So you do that by sharing oxygen atoms between those tetrahedrons. You still don't satisfy all of the negative charges. You satisfy a portion of them. You just keep sharing tetrahedron to tetrahedron to tetrahedron to tetrahedron. There is a remaining negative charge that's left. This is key because this is ultimately going to be that charge that we're going to talk about that is important for attracting the cations, which are our soil plant nutrients. We can also make what's called an aluminum octahedron. So if we take a look at this, we have aluminum surrounded by 6 oxygen atoms, and in that it makes an 8-sided arrangement that we call an octahedron. Why aluminum? Because aluminum is the third most abundant element. Why is there more oxygens? Because oxygen is the most abundant element. Okay, we can also make these octahedral sheets, and we make them in the same way that we made our tetrahedral sheets. We just take the octahedral sheets and we share some oxygen atoms in between. In this case we're sharing 2 rather than 1. And we aren't able to satisfy all of the charge. You can see that aluminum has a +3 charge and every one of these oxygens has a -2 charge. So there's going to be a lot of overall net negative charge that's going to remain on this octahedral sheet. And you can envision that rather than just 2, you would actually have thousands of these things that would be bonding next to each other that would create the octahedral sheet. So we have a tetrahedral sheet which contains silicon, 4 oxygen atoms and 1 silicon atom, and then we have the octahedral sheet which is 6 oxygen atoms and 1 aluminum atom. Regardless, in both sheets we have a remaining negative charge, and it's going to be these 2 sheets, the tetrahedral sheet and the octahedral sheet, which are going to become the foundational building blocks for our clay minerals. So our silicate clays, the tetrahedral and octahedral sheets are the building blocks. So in our next series of videos, we're actually going to take a look at taking these tetrahedral and octahedral sheets, and we'll start to stack them together and bond them together, and we'll make different types of clay minerals in the process.